It is now my pleasure to introduce to you today's presenter, Fred Romig. Take it away.
Thank you, sir, and welcome everybody to this good presentation that's forthcoming. So here's what we're going to talk about today. We're going to talk about keeping your environmental safe. Now, I'd like to get into two unique features having to do with hazard chemical buildings. These exclusives are spill containment and low-level ventilation systems. We will include fire suppression as a third topic. Keeping your environment safe via spill containment. A chemical storage building's most unique feature is that it must have a liquid-tight sump built into the floor. Sumps are constructed of either continuously poured concrete curb integral to the concrete floor or a continuous welded 10-gauge steel plate for sump walls and floor. Next slide. The idea is to catch spills and keep them from getting into the soil under and or around the building. Just how much containment is required or how high does the sump walls have to be? OSHA code paragraph 1926.152 requires a 4-inch sump depth or height when a fire sprinkler system is installed. Now this is silly because not all hazmat buildings are required to have sprinkler systems such as for non-combustible chemical liquids. The EPA code paragraph number 20 CFR 264.175 requires a sump capacity to be 10% of the total of all the containers stored in the building with or without sprinkler systems. A more practical answer. Common sense and being practical is also required. If the containers are sitting down on the sump floor, then the amount of sump capacity or its wall height must be increased by the displacement factor of the total number of the stored containers. If the containers are placed on an elevated floor, then any of the support structure involved in the elevated floor's construction is also to be considered for its displacement factor. In the late 1980s, Factory Mutual, and that's known as FM, was brought into the picture because hazmat building manufacturers wanted a qualified third party to review building designs. This qualified their proposals to prospective clients that their building met certain safety codes, especially the National Fire Protection Association NFPA 30, which is called the Flammable Combustible Liquids Code. This is the only code with a simple chapter devoted to factory-produced steel chemical hazardous buildings, listing all required elements. But it lacks details. For example, to find out how low a ceiling can be, it's not in NFPA 30. You have to refer to OSHA Title 29, paragraph 1910.37I. It says the distance must be 7 foot 6 inches from the chemical storage building's elevated flooring to the finished ceiling. Even though NFPA 30 agreed with the EPA, FM, on their own, raised the sump capacity from 10% to 25% of what's stored. For storage of common 55-gallon drums sitting on an elevated floor results in the sump floor wall having a minimum height of 6 inches. You can begin to see why knowing what's in what codes is very important. Other factors must be considered that determine sump floor height. If there is a water-based fire suppression system, the capacity of the sump height must add in the total amount of dispensed water in a 20 or 30-minute deluge. This is dependent on local codes and or opinions of the local authorities having jurisdiction. And this is because the spilled chemical usually will not mix with water but will float on the surface of the rising sprinkler water. This cannot be allowed to pour over the door sills, out of the building, and into the environment. The calculated water catch will result in sump heights usually greater than 20 inches. The sump floor may be sloped. If the slope is 2 inches from the high to the low spot, the total sump height needs another inch. Sloping the sump floor allows for easy drainage during sump cleaning. There may be a lot of dirt tracked into the building over time that needs to be cleaned periodically. A spill is required to be cleaned up immediately. The slope should flow to a slope trench for faster drainage and places the buildup under the aisle of the elevated floor, which is usually made of grading. If the chemical on the surface of the water catches fire, it will not be cooking the bottoms of the remaining containers on either side of the aisle. The fire will be exposed directly to the fire suppression system that would be on the ceiling.